My name is Ilja Jaroschewski. I'm picking off where Fabian left off. And myself, I'm a postdoc currently at Paris-Saclay as Fabian, and I'm working with gamma ray burst and supermassive black hole mergers and Astro-COLIBRI, of course. And I'm presenting to you our interfaces and how to use them and what they can do. So let me start off. I will talk about the astrocolibri.com, so the website, and the app version, which you can see here on the right side, and the API, so the calculations and everything in the backend will be taken over by our colleague Bernardo later on. So if you click on this website, which you can see here, the link to the astrocolibri.com, you will land on this page first. This is the non-science mode version of our website. As you can see here above, I hope you can see my mouse. You can see that the science mode is off, and it's just a version of our website which doesn't give you too much information at first, so that you open it, it doesn't. You know what to do. Here on the top, you see, first of all, the timeline, which is in default settings put to 7 days. So here you can see all events from the last, so all transient events that were detected by various telescopes and observatories and send push notifications. They all appear here color-coded and coded as symbol-coded. You can also change the start and the end time of your timeline. Here for the left side and on the right side, there's also one icon there, so you can put on the time range of transient events that you want to see dynamically. Here is, for example, if it's set to 7 days, there were 67 events, but when you put it on, for example, 2 weeks, so add 7 more days, you get a variety of events more, and you can see that the timeline gets more crowded here. On the left side, you see for each event a so-called card tile, which consists of the event name, for example, here the SN225 MVG, then the type of event, so here supernova, here an unclassified optical transient or gamma ray bursts, etc. And the symbol for it. So, for example, supernova is a filled star, unclassified optical transient, an unfilled star, and gamma ray bursts, for example, bursts as dots in a different color. And this represents to the symbols of events in the timeline as well. Then you have here tile where you have more information about the events, like the date of observation, the position in the sky and which observatory detected it, and on the right you have a summary of the source or generic more information about the source as well. In the center, you see the sky map, the sky map, which contains the same symbols as in the tiles and in the timeline. And if you look at it in more detail, so by default you have equatorial coordinate system, so that you see the right ascension declination, but you can also change this in options. You can zoom in and click on each event with a mouse. So if I want to see an event here, I can just zoom in and click on it, and then their respective tile will be chosen, and you see more about the event. And you see here, for example, this galactic plane, the blue line, visibly in this coordinate system. And in the bottom, you have also more external information about the event, so you can follow up with various of links, which also Fabian talked about a little bit. This is the, for example, Zimbad, another data database or where you can look at the event. And if I, for example, what I mean by it is you pick the supernova, you have here the tile which points to the ESA sky, you click on it, and then you see, for example, where the supernova lies. So this is the short introduction into our non-scientific mode. So basically, you have just an overview over all events on the sky map, and can click on it. Now I want to talk about a little bit about the science mode, which contains more functions. It's basically like that. So you just click here on the upper right-hand side. You just click on it. Then you've got the science mode activated. So you've got a green button. And what you see, what appears is this filter sections above. Here you can choose observatories and event times to filter. So you got here the color codes for observatories and event types in the bottom with respective symbols. And what this means, for example, if I'm not interested in gamma ray bursts, not interested in bursts, no neutrinos, no gravitational waves, or unclassified optical transients, I'm just clicking on these buttons, and then they're not highlighted anymore in this filter area, and they disappear from my sky map. So now I have only the events that I'm interested in. So for example, only classified optical transient and supernova, because there were no fast radio bursts or neutrino electromagnetic counterparts during this time observed. Great. So, but you can not only filter by the types, but you can also filter by magnitude. For example, if you just long click on some of these buttons, for example, affect optical transients, you can filter for its magnitude. Then you can also filter for different types, for example, TDEs, supernova, variable stars, and so on. The same for different supernova types. Then you can also filter for different observatories. So some that are not interesting for you, for example, you can filter out. And we've got a general filter where you can filter for the visibility, so the zenith angle that should be visible and zenith angle that is not interested for you, and different follow-ups can also be filtered on. And if it's active, for example, here, and it's also a sun distance filter applied for telescope chosen, and you see here this variety of events is now visible because of the zenith angle, which has set to 60 degrees. So everything which is not visible from my respective telescope here set to has is not visible anymore when this button is active. And you can do several different things for it. So you can assess visibility of your own telescope with for it, for example, with supernova, and you can just see, okay, how many supernova have occurred in the last year to assess how many you could have observed and maybe can observe in the next year. So I just click on everything. So I filter everything but supernova and put the time range for a year. Then I have here nearly 2,200 events. Then you can filter them to see how many were observable, for example, by Gaia, so with a different magnitude. So you have almost 300 less events for it. Then you can see, okay, how many supernova could have been observable by my telescope, and you can set a magnitude, for example, smaller 15, and you see, okay, that's only 5 events. And then you can see, okay, how many could I have seen by eye, and there are 0 events. So everything is customizable how you like it. And when we, in this science mode, we've got also more detailed information about the sources. So on the left side, where you have the source tiles, you see also the date of observation and the right ascension declination and the errors of them. The same here in the center, and here on the right, you have more information about the source, like which observatory it has detected it, what is the error of it, and so on. Here in the center tile, you can also do a cone search. So just click on this button. And what we want to see is, from my respective source, you zoom in. So the zoom is done automatically. And you see this picture on the right, where you see the source in the center and a 10-degree cone around it with different points inside. These points are catalog sources of known sources. So in this case, 4FGL, TEFCAT, and IceCat, so neutrino sources, tera-electron volt sources, and gamma ray sources. Then they also appear here left in the tiling. And when I go into it a little bit, you see that this IceCat, so the neutrino catalog sources have round symbols. The 4FGL catalog sources squared one, and the TEFCAT red one. And you can also set this custom 10-degree uncertainty line around it. You can also make it smaller for 6 degrees, for example, and see what kind of sources are then inside of it. And you can also filter this 4FGL sources to have only starburst galaxies, for example, if you're interested in supernovas. And then only they will appear. So as I mentioned, there are more detailed information standing here on the right side. And it has some information like when it was detected, what detected it, but also what was the brightness of this event when it was detected. Seen, for example, here with the DAG brightness. You can download all this information also with this download button, and you get it all as a JSON file. And this can be then used for your further own scripts or with our API, and this will be talked about, or you will hear about it more in Bernardo's talk about the API later on. So here you have also an archive button where if you click in, you see also archival data about the source. So each time we get a new push notification, we update the source, but the old infos are not deleted, but they are stored in our archive, and you can load every version of this updated source to see how it evolves. And if you see that for example, something changed now at the source but was different prior, and you want to know what it was and what the prior information was, you can also go back and see it here in this archive. Then we have some special event plots for several of our sources, which are just shown here, a variety of it. But what I want to talk about is the light curve for the sources. So seen here. Because it's the most useful thing for optical transient. So you see the light curve for sources from which we do have a light curve. You see it in small in this event information, and when you click on it, it will enlarge. And what you see here is on the right side, you have the different detectors and filters are shown, so color coded. Then you see as triangles, you see the upper limits of the respective detectors. The data points are as round symbols. You see the error bars, and you see also some binned data points if we have several detections nearly at the same time, when we bin them together to make it all more user-friendly and to see the data better. Then you see here on the right side, you see when the plot was created, and it's created 2 times a day automatically. And it's also downloadable here with this button above. But you can also produce your own light curve or a custom light curve for the source. This is, if you see here, this white arrow, and you click on it, then you see something which looks like this. And here you can also change the time of this light curve. So here it's done for 2 weeks, but I can also click on one of these buttons and set the first date, for example, for the 1st of May. And then I can create the light curve if I click on this button, and it will cover this month and 7 days. It may take some time to calculate it, but then you will get a figure like this, where you see, this is what I've shown you earlier, and now you see that in the past there were only upper limits for the source, so it wasn't active, and at the time of the detection was the first time a real detection was made in this source or for this event or in this event area. And if you have for different light curves, you can also, for example, like this supernova, you can follow these events, and I will show you a little bit later also how. And if you think it's different, so you can follow it and see when it rises and when it falls, and can schedule your own observations and yes, do that. There's also amount of external links is larger in the science mode than in the non-science mode. And to follow an event, a user account is it's good to have a user account. Let's say like this, and I'm telling you, will tell you now why and how it is useful. Of course, as Fabian also said, it's all isn't connected to any charges whatsoever. So if you click here on this user button, you get here into a login area, and if you click on create a new account, you can create a new account here, and you see it when created, and you get a confirmation mail. You have to accept it, and then you see here you are logged in with your email address. And when you click again on this user button, you see, you are now logged in as a user with this and this email address. And if you click then on account details, you get the account settings for your profile. And what is important here is this user ID, which is important to use the API and will be covered by Bernardo's talk later on as well. But you can also set here for some things like number of digits in your coordinates, which are shown, or the default time period in the time range, which is shown in the time range above. Okay, great. So what else can you do? You can also request observatory access by clicking on this button, and you see something like this, where we have some observatories predefined, where you can click, you can state your reason for the request there and send that you want to request an access. Then we will get an email notification and can test your reason. So, for example, you're a member of HES, like in my case, and then we can access you or grant you access to this observatory, and you can combine it with Astro-COLIBRI. And what I want to show you is how to get a TOM access, which is a toolkit you used. And here's an example if you use it with BHTOM, which you will hear more about in the afternoon. You can just click on it and then enter your BHTOM credentials here and log in to BHTOM via Astro-COLIBRI. And when done, can directly submit sources from Astro-COLIBRI to BHTOM. So you don't have to switch platforms and can do it all in one platform. If it's a TOM or TOM like website, which is not in the list, you get also something like this, where you create a new entry in our database. And this is everything which it contains the websites or the links which is necessary for us to make this all submission working. And if done so you're logged in BHTOM via Astro-COLIBRI, you get here something like start follow-up campaigns pops out, and you click on it, and you can see your tiles which are connected to each of the observatory. So if I'm interested in this source, I can just click on the BHTOM button and can submit the source directly into BHTOM over with my name. And for example, if you then access RAPAS data, which will be also covered later, I think in the at noon. You can also create a light curve where you can show also RAPAS data in it, and then see your observations done. What is also useful if you have this user account is you can add the sources to the watch list, and each file has now this plus on the lower right side, and if you click on it here, it will be activated, and it will be seen each time you upload it. You will see this tile of your sources that you want to follow, and if it's outside of this range that I'm looking at, it will appear at the end of this event tiles, so you can always see your sources, and it is also visible here in the map. All right, what else can you do on the web page? You can change your observer location here with this location button, and you can set and save your location if you have a user account cross-platform. So here, for example, I used the app on my smartphone. I put in my current location, called it Paris, and saved it. And now everything is done. Everything is calculated in the app based on my observatory in Paris. This is prominently seen in the visibility plot, which is also here on the right in the info area. And if I click on this plot, I see it enlarged. And what I see here is in dark, the dark time. So the time where I can do observations. You can see the source here independent of the azimuth angle as this line. The sun is the red curve. The moon is the dotted curve. And you've got some instrumental constraints concerning the altitude here. And for example, this plot was done based on the longitude, latitudes, and height, which are set in the observer location. So you can plan your observations based on this. And if I change now to Hess example, I just want to show you how moonlight will look like. It's just like here. I think 2 days ago or 2 nights ago. So there's only a small visibility window because the moon is too high up and will interfere with observations. And this visibility plot is done daily, like I'm showing here, or monthly, where you have something like this and have to see how or can plan your observations like this. You can also see some other features which I will mention briefly. You can also search for specific sources with the search button. You can share the event via a link, so you just click on it and get an URL. You can download all the selected events as a JSON file, and then you can do something with them. You can change the coordinate system shown here in the sky map. So this is equatorial, but you can set it also to galactical. For example, you can change the theme of the interface. This is the default one, but we have, I think, two more. And you can check the version and documentation of everything what you've seen. This is for the website. So an overview of what you can do with the website. How about the app? So here, if you download the app on your smartphone, so from the Apple Store, Google Store, and open it, you will see something like this. This is the landing page. Where you see here the sky map, the event which is chosen, and the event tiles. This is also done for science mode. You have also, but you also have a non-science mode in the app version. This is here the leftmost button is activated. If you click here on the second button, you are doing a cone search for this event, so this GRB in particular, and see all the sources around it. When you click on the third one, you see the visibility plot and can enlarge the figure the plot, for example. And if you can click on the rightmost, then you will see the source info. So like the sun distance for it, or the location, the errors, etc. And the light curves is also here. So this is how the app version looks. Then if you go into the menu, you see different tiles which you can which you see, for example, the science mode or the account settings where you can log in as well. You can also do a tutorial, or if you skipped it, we start a tutorial if you click on this button. But if you click on the notifications, you will see something like this. And here you have some headlines like gravitational waves, optical transient, general alerts, etc. And if you click on them, you can click on each of these things and customize for what you want, which alerts you want to receive. For example, only for supernova, or all gravitational wave alerts, etc. And this is then what you will receive as an alert notification on your smartphone. Yes, you can also, if you click on the account, you see the account details. And here's also something in addition new compared to the web version, which is the smart home connection. And here, if you have a Hue system in your home, for example, Hue lights, you can click on it and connect to your smart home system. And then each time you receive an alert, you can set a color, and you will receive a blinking from your smart home system. We've got a whole tutorial for it, how to set it in place. It's really straightforward, I would say, but if you are interested in it, just get back to us. Yes, when something about the community, Astro-COLIBRI, and what I haven't talked about is we have our own forum, which is, if you see here, this speech boxes symbol, and here in the lower you have something like discuss this event in our forum. And in the web version, you have this in the settings. If you click, you have also a discussion forum tile. And if you click on it, you'll visit our forum, which is this website. And there several events are discussed in the community and are open for discussion. And there we are also posting something where you can vote for the most interesting sources which you want to observe, where we give you an overview. So there's a lot to see and to discover here, and I won't go into much details around it. Yes, and I think that's it from my side. So you will get more about the API, or will learn more about the API in the next talk by Bernardo. And feel free to contact us if you have any questions, you encounter issues, or just need help. Yeah, thank you.
Thank you very much. I see we've got a question from Sarah.
Yeah, thanks for that. It's really, really interesting. Just wondering, have you got any training tools already written, like example activities, sort of walkthroughs so that you can get acquainted with it?
Do you mean for the interface or for the data?
For the interface. For using the interface.
We have some YouTube videos and tutorials which you can follow. So if you follow us on YouTube, there's several use cases also discussed in
Okay. Have you got any sort of written ones, or are they all video ones at the moment?
We have written ones, also documentations for the whole API, which Bernardo will talk about. But written, you mean that where you have picture of the front end of a website?
Yeah, because I'm thinking about using this like with school students and with university students, and sort of documents to give them with screenshots saying, okay, step 1, go here, step 1, go step 2, do this, if you're looking for this type of object, that sort of thing.
As we have for example, our presentations like this, but if I'm not mistaken, and Fabian and Bernardo can correct me, we don't have just a written manual of this, how you can, with screenshots, what you can do.
Okay, that's fine.
We've got there's a question from Stephen first, I think.
Yes, thanks. So actually, I noticed there's a question in the chat. So on behalf of Zakar, I'll ask that question first, if that's all right. And he's asking, or they are asking, if there is a Linux version of the application.
I mean, the application. So what I'm showing you is the web version. So you will see it in every browser. There is no. You don't have to install anything on your laptop or your PC. It's only you're just opening a browser, and then you'll see it. It's only for the Android, or for your smartphone or your tablet, where you need to install it from the Play stores. But other than that, it's just a website, so it's also usable from Linux.
Oh, that's really good to know. That's really good to know. I'm just also imagining people in. There's probably someone, a Linux fan, who has installed Linux on their iPhone or something just because. But
yeah, then yeah, if it's Linux installed on an iPhone, you need. I don't think apps are working anymore, but I'm never heard of it, to be honest. Yeah. But then only the web version is fine enough.
But the web version is great. I also had another quick question. It's a bit of a geeky question. It's that in various astronomy projects and beyond astronomy, open science projects, there's been an effort to coordinate the login technology, the AAI, the authentication and authorization infrastructure. And you've got your own login system. The coordination has been trying to coalesce around EduGain. I don't know whether it would be a lot of resource to try to implement that in Astro-COLIBRI, or is it should that just be an aspiration for some beautifully funded future?
So my initial thought is it's something for the future. So because I don't know, so it won't be straightforward to implement it from our current system, because there are also some updates currently going on from the tool that we are using to update it. So to combine it with, we can look into it, yeah, but I honestly cannot say how much of an effort it is right now.
Okay, so that would probably be an offline conversation that we should definitely have. Yeah, sure. And there's someone else with a raised hand as well, so I'll stop.
Go ahead, Thierry.
Yes, yes. Thank you very much for your presentation. And yes, Astro-COLIBRI is a very nice application for, particularly for the RAPACE project. My question is about the Vera Rubin telescope, which will be ready to deliver transient events at the end of this year. Do you intend to do something special, or does you will feed in all the tsunami of events we may foresee at the end of this year? Do you intend to do something special with the Vera Rubin outputs?
Maybe a quick question. What do you mean something special?
I don't know. We may foresee. I remember the presentation we had last year is maybe a million or even more events a year from the Vera Rubin. So
we will definitely implement, so the events will be distributed via broker, and we will implement this broker into Astro-COLIBRI as well. Yes, depending on the events or the amount of events, which we will see. So it is to be seen how many there will be in the end, but with the filters, maybe we will have to adjust some filters. But if I'm just thinking about the current system, we'll see if it's too many events, and we can set some sub-filters or adjust something. But right now, we don't see the hurry to do something for it.
okay.
That's it.
Thank you.
Maybe just to complement that, I mean, this will certainly be also a learning experience for all of us, because as you said, Thierry, I mean, there will be tens of millions of alerts per night coming out of Rubin LSST, and there's no way we can ingest all of them and show all of them in a reasonable manner in our interface. So this will be completely overloaded. But then where to draw the line, which of the events are interesting enough to be ingested in Astro-COLIBRI will be a learning experience over the next year and a half. And so we have put in place contacts with the European brokers to be able to ingest these events. There's also, within the work package that I lead within the ACME project, a collaboration between these brokers so that we don't get the same event classified 3 times differently, although we can already deal with that. So you can select different brokers and say, I like the French broker, which is called Think, or I like the UK broker, which is called Laser. And then you only see the events coming from these. So this is all put in place on a technical level. But then we are also looking forward to feedback from the users and the community of what you actually want to see and which alerts are actually helpful and useful for you. So we will be in contact with the community again once we get the first alerts to see which kinds of sources are interested to be highlighted in Astro-COLIBRI and which are not. So that's why I say it's a learning experience, certainly.